Okay. Fine. So just we'll start with what is a process in an operating system. So when we come to operating system, we have one more important topic called as process synchronization, which is a very important topic once again. Okay, and a important chapter for examination point of view as well. So till now we have seen what is the process and how the process is going to work. But we will come across something called as synchronization. The meaning of the term synchronization is two or more processes working together in coordination. That is what is called as synchronization. Okay. So here normally till now whatever we have understood, how the things are going to be is if a process is executing, other processes will be in the waiting room. Remember the process state diagram? We have 5 different states: ready, running, new, ready, running, waiting, and terminated. I hope everybody remember those things.
So,
Yeah. So when the process is ready to be executed, it will be in the ready room. Then whatever process is getting executed, it will be in the running room. So if any other process comes, it has to wait in the waiting room. Remember that diagram,
Yes,
everybody?
sir.
Okay, fine.
so
So the process which is getting executed here is what we called as the process which is running. Here we have one more technical term for it. We have one more thing called as critical section in a process. What is critical? What is the meaning of the term critical? Something serious.
Serious.
Something serious. So here, when we come to the process, in process also we have something called as critical section. That is, if we see in terms of process, don't see in terms of human nature, but see in terms of process. When a process is there, when it is getting executed, when it is trying to give some output, then that execution part is what we call as critical section of a process. Okay, the execution of a process is what we call as, or running of a process is what we call as critical section. Clear? Okay, so we'll see those things. So the most of the things that we are going to cover in here is how the processes are going to work in coordination with each other. Okay, how they will share the resources among themselves. If one resource is having one resource, suppose simple example, from the beginning we have taken something like Zoom and WhatsApp and a phone call. If Zoom is accessing an input and output, okay, that is audio and video. Okay, if any other device wants it, it has to wait. It has to wait for that resource. So what is happening here? It is going to put the lock. Suppose we receive a phone call. Then what is happening? Phone call is able to access audio. At that time, Zoom is automatically muted. That is, Zoom, the phone call has put a lock on the audio things, so that Zoom or any other things will not be able to use it. So those things, how the synchronization and how the locks are going to work, that we are going to see, and how synchronization really affects. So this is what we are going to study in this chapter. Okay. So first thing is how the processes are going to work in coordination with each other. That is, when two or more processes are getting executed, how they are going to execute, how they are going to share the resources. What do you mean by resource? What are resources of WhatsApp? What are resources of WhatsApp, ma?
Video call, audio, texting,
Video call,
chatting.
audio call, all those things. Good. Suppose if we receive a phone call is putting a lock on the audio. So that Zoom or any other app will not be able to use it. for time being. So that acquiring of blocks, protecting of blocks, giving of blocks, releasing of blocks, then how the synchronization exactly works. This is what we are going to study. So as I've said, we have something called as critical section. Then we have other things like what are various solutions, beta solution, synchronization of hardware, semaphones, and how the synchronization problems are going to be. All those things you're going to study. So exactly what is a critical section? We'll see that first. First we'll see what is the critical section. Then we'll come back to the other things. So when we come to this critical section, as I have said, the place where the process is getting executed is what we call as a critical section in simple terms. Simple terms, the place the process is getting executed is a critical section. Okay. Even I'll have one animated video. I'll show the video also how the critical section is going to work. Okay. So in critical section, we have entry, then execution place, that is critical section, exit, and reminder. We'll see all this four. I'll show the animated video, then you'll be able to understand how these four things are going to work. Okay. So entry is nothing but it is entering into the place. It is entering into the process of execution. Then it is started its execution. Once it has completed, it is going to exit that critical section. Once it has exited, it is reminding, it is sending a reminder to other process, those who are in waiting to enter the critical section. Okay, so just I'll share a video so that you'll be able to understand the things in a much better way. Just I'll on the just see this video, you'll be able to understand the things in a much better way.
After understanding the process synchronization need, that was interdependent and dependent processes, and we would be concentrating more on cooperative process, that is interdependent process. Let's try to understand one of the most important thing of process synchronization called critical region. In some cases, it is also known as critical section. Let's try to first understand the basic terms. In a layman's language, what is critical region? Critical region is something which can be accessed only in a one at a time manner, kind of a mutual exclusion. There's a small example which will explain the same thing. Consider there is a room, maybe a fresh room, in which there is a queue of n people standing. Now, the room can be used only by one person at a time. Let's number them. This is person A, let's say this is B, C, D, and E. Considering that A has already gained access, others are in waiting, and A is within the critical region or a critical section. The moment A finishes its job, what would happen? A would simply come out of it, and from the waiting queue, depending on some algorithm, Mr. B enters the system. Now C, D, and E are waiting. The moment B will finish its job, again the same thing would happen. B would go off, and probably the next one, C, gets in, and the system would repeat. So basic idea over here is to understand the critical region is a specialized region which can be accessed one at a time manner. The term is known as mutual exclusion. This can be used for several things. Now, if we practically try to understand how critical region and why critical region, let's try to put it. Every program will have some part which is needed to access in mutual exclusive manner. Now this some part may refer to file access, database access, can be some variable access. Now This kind of access would require special attention. Why? Maybe when a program is accessing a particular file, maybe that file is used by 10 other processes. By this process, changing this particular file, X, Y, and Z would be affected, which we don't want. Hence, process A would require mutual exclusion so that only it can access, modify the file, and then later on others can access this information. Similar can be seen or understood for the database access or for the variable access. We don't want anybody to suffer when one of the process changes any data, file, or a table. So, as we have already talked about the waiting and the critical region, let's try to analyze in a programming language what basically entering critical region would mean. Well, there would be a loop which will monitor the activity and which will run till the time process needs to access again and again. That does mean that when process C gets out of it, it not necessarily finishes. It will go back at the end and wait in a queue to again enter the critical region. What exactly critical region programming wise would do? It is the endless loop till the time we have a true, that means till the time there is a need. So what all we do? We first make a request to enter critical region. The moment you gain access to the critical region, what you would be doing is do some task. Now do something would be accessing file, database, or anything as we have said further. Similarly, it is your duty when you come out, you will also fire reminder. Why? Because consider an example. When process C comes out, its duty to inform process D to get in again. So what C would say? Process C when comes out would inform D go in, and at the same time this D would shift from the outside to the inside. So basically this is how critical section is supposed to work.
I hope you people are able to follow it. Yes, ma'am.
Sir.
Able to understand? Yes? No?
Sir.
Just I'll show the things. See here, if you are able to follow the things, here we have 5 different processes. Process A, B, C, D, and D. 5 different processes want to execute. So here what happens, only one process can be executed at a time. So process A has entered. When process A has entered and it is ready to execute, other processes B, C, D, and E are waiting to be executed. Once A has completed its task, then B is entering. So like this, one after the other. Once B has completed, C has entered. So these are the processes will be executing one after other. So here, the process execution, it can, when it is executing, it requires some resources. The resources can be in the form of file accessing, that is accessing a file, any file in a computer. It can be a database access, or it can be a variables access. So these are all what we call as resources of a computer, which will be accessed by the processes. Clear? Follow till here.
Sir.
Okay. Now suppose the process A, if it is accessing a file, the process A is accessing a file. So at the same time, the process X, process Y, and process Z also want to access a particular file. Suppose process A is modifying a file. Those modifications will be affected to process P, I mean X, Y, and Z. Yes or no? If the same file is been opened by many people and they're modifying it, will it not affect other people also? Will the data be proper? Will the data be proper?
No, sir, it will
Sir.
affect.
No, sir.
It will definitely the manipulated data, or it will have some problems over there. So it
Yes,
has
sir.
to be stopped. It has to be restricted. So what it has to do is either it has to give a permission for all this process to read the data, or if it has writing the data, it has to give permission for only one process. That is, this process has to keep a log so that other process will not be able to access it. Clear? Then next thing, how the problem is going to work. So when the process is coming out of a critical section, it has to inform other process. It has to inform other process. So what it will do is it will keep something called as reminder. At the last, we have something called as reminder. That is, here what is happening is when a process is coming out, it has to inform the next process that I have completed, you can get inside. That is something like reminder it is going to give. So like this, the things are going to work out. Clear, everybody?
Yes, sir.
Are you able to
Yes,
follow
sir.
this mark? Everybody.
Sir.
Okay, fine. All are able to follow this, I believe. Yes? No? Tell me something.
Sir.
Sir.
Yes,
Good.
sir.
So this is the problems are going to be executed. The things are going to be executed inside a computer, one after other. If two or more things have to be accessed simultaneously, then that is what is called as synchronization. How the synchronization is going to work, how they are going to access, okay, how they are going to be useful, and how the things are going to be. Like this, we are going to study what is the synchronization, and the first thing that we are going to study in synchronization is the critical section problem. Okay, that is critical section region. In critical section region, how the things are going to be, how the things are going to be executed, all those things we are going to study. Then followed by various other things like semaphones, Peterson solutions. So what the problems of critical section, how they are going to overcome? They are going to overcome by Peterson solution. So like this, the things are going to work